the title for our research proposal is the feasibility of spent coffee ground as a feedstock for production of bioethanol in Saccharomyces cerevisiae. My name is Dayang and Syafiqah, and the other two members is Farah Munyati and Intan Atira. Next, to introduce our research proposal, we will be using spent coffee ground as it is the residue from the coffee brewing, and it comprises of huge amount of organic compounds, for example, lignin, fatty acids, hemicellulose, cellulose, and more polysaccharides. But it was only studied in the beginning of the decade for its use in biorefinery platform. Hence, we will be conducting the enzymatic hydrolysis on the substrate of acid G to enable the obtaining of the fermentable sugar. Hence, for this research, we will be conducting the insertion of S. cerevisiae yeast strands, plasmid transformation, and the screening of beta-manganese enzymatic activities. Next, I will pass to Intan.
Okay, so while conducting this research proposal, we have come out with our problem statement and hypothesis. And one of those problem statement is we want to study, does the range of concentration of enzyme being used result in different concentration of product from enzymatic hydrolysis? And for the hypothesis, we believe that the use of spent coffee ground (SCG) as biodiesel feedstock helps in the plan of valorization. So the others hypothesis is stated here, and also the problem statement. So moving on to the objectives, we have come out with 3 objectives, and one of those objectives is we want to observe the characterization of enzyme manganese in the SCG substrate. Moving on to the literature review, first I will explain about Saccharomyces cerevisiae. Saccharomyces cerevisiae is a unicellular eukaryote that is classified under the kingdom of fungi. This species is one of the emerging fungal pathogens with a unique characteristic to ferment a wide range of sugars and is considered as the top fermenting yeast and a valuable species for a various industrial application such as beverage industry. So for bioethanol production, well, in 2020, the United States produced over 13.9 billion gallons in a year, and the market size for bioethanol is projected to reach USD 64.8 billion by the year of 2025. However, in Malaysia, the production of bioethanol is insignificant due to high cost of production. The illustrated graph shows the global ethanol production by country or region, whereby 2019 is recorded as the highest production of ethanol. Thus, due to its global demand, it is important to devise an efficient and effective way to produce bioethanol. Well, we might wonder how spent coffee ground can be used in producing bioethanol and why. Around 50% of coffee produced worldwide, and in 2014, according to Salomon, around 9 million tons of SCG were dumped in landfill. Thus, the conversion of spent coffee ground to biofuel and value-added product is gaining importance from the point of view of sustainable waste management policy. It is crucial to carry out this conversion. So moving on to the DMSO method, well, transformation process in strain of yeast of Saccharomyces cerevisiae is important in resulting the genetic modification of fungi. The MSO method or lithium acetate method is one of the methods to transform the strand of Saccharomyces cerevisiae as it introduces the exogenous DNA into a cell and causes genetic modification. Next, I will pass to Farah.
Okay, thank you, Intan. So after the DMSO method, we move on to the enzymatic hydrolysis of spent coffee ground. According to Just et al. 2013, out of the enzyme tested on spent coffee ground, the use of manganese enzyme produced higher yield for hydrolysis. The highest increases in soluble solid yield were obtained with recombinant manganese, which is MAN1. Okay, next slide, please. Okay, next, the concentration of enzyme is among the most major factors determining the enzymatic hydrolysis process. In most industrial areas, a high enzyme concentration is preferred because more enzyme convert more substrate moles into product. From the graph shown, according to Haslaniza et al. 2010, when the percentage of the enzyme was increased, the degree of hydrolysis will increase too, due to the enzyme hydrolyzing some of the related peptides into amino acids and also smaller peptides. James et al. 2005 also stated that the increasing enzyme concentration will reduce the hydrolysis time more than increasing temperature. Okay, next slide. Okay, here we can see the bioethanol fermentation by Saccharomyces cerevisiae. Fermentation is at heart of the ethanol manufacturing process. According to Muhammad Azhar et al. 2017, a variety of yeast strain, including hybrid, recombinant, and wild-type yeast were used in the ethanol fermentation process. It is also stated that minus fermentation in Saccharomyces cerevisiae yielded about 80% of the theoretical yield, suggests that it is a viable technology for the ethanol production. Okay, next I will pass it to Dayang for the material and method.
Thank you so much, Intan. For this experiment, the chemicals that will be used in the experiment will be of the analytical grade, and the substrate product preparation is the method based on use at all, which is the drying process of spent coffee ground by removing the excessive water from the spent coffee ground by increasing 50% dry method to 90%. And method by Blackini of two-stage sulfuric acid hydrolysis is to estimate the content of polysaccharides in 0.25 gram of sample containing SCG and the roasted coffee beans. The samples will then be neutralized to pH 5.5 using calcium carbonate and will be centrifuged. The centrifuge product, which is the supernatant form, will be air-dried before undergoing reduction acetylation using sodium boron deuteride and acid anhydride. Next slide. For the strains, specimen, and media, all of the applicable genotype as STF2083 strains that will be used are obtained from a study by Fuchs. The preparation method will be based on a method by Fuchs. Media that will be prepared is a 20 milliliter of double-strength synthetic complex (SC) medium containing yeast, nitrogen base without amino acid, and ammonium sulfate, glucose, and ammonium sulfate. Amino acids will be supplemented to the media, buffered at the pH 6, and STF2083 strains will be put in the medium to be cultivated. And DNA manipulations method will be based on a study by Sandberg et al. And the digested DNA will be eluted using Zymo Clean TM gel recovery from Zymo Research Corporation USA. And next, a PCR reaction will be conducted under the specification of Inca Biotech located in South Africa with specific primers based on the method by Fuchs. Next, the yeast acerbicate will be transformed based on the lithium acetate or DMSO method by Hill et al. Next slide. The beta-manganese activity from the transformed cells will be screened after washing the cultures of the grown strains on the selective SC agar plate within 2 days. The plate will be stained with 0.9% of Congo red solution and is stained using 1.2 mol of sodium chloride solution to make the hydrolysis zone visible. And the enzyme assays will be done by determining the optical density of the enzyme samples based on a method by Olsebel et al. The manganese characteristic in the substrate solution can be observed as 0.25 galactoglucomannan or locust bean gum is added in the enzyme samples. Reducing agar, which is mannose, is determined with dinitrosalicylic acid method by Miller et al. Hydrolysis method will be done afterwards based on a method by Yus et al. By adding the enzyme sample into the substrate prepared earlier to determine the enzyme activity, which is equivalent to 1 nanomole of producing sugar. And lastly, the enzymatic hydrolysis of the spent coffee ground will also be conducted based on the method by Yus et al. By wetting the spent coffee ground, adding the enzyme sample in different concentration in the range of 0 to 10 nanocata per milliliter to study the effect of enzyme manganese on the soluble yield of spent coffee ground. And next, I will pass to Farah.
Okay, thank you, Dayang. By the end of this study, it is expected that the effect of using different concentration of enzyme manganese on spent coffee ground substrate yield will be studied. The best combination of manganese cocktail for enzymatic hydrolysis were 0.5 over 0.82% and 0.01 over 0.91%, releasing 20.6% raw SCG and 22.6% pre-treated SCG soluble solid. Next, the relationship between the concentration enzyme and degree of hydrolysis will be further understood by performing this study. When the percentage of enzyme was increased, degree of hydrolysis will increase too. Lastly, the activity of beta-manganese from the recombinant strain of S. cerevisiae and the characterization of enzyme manganese in the SCG substrate will be observed. This study will contribute to the new information for future research, potentially leading to new findings about the enzymatic hydrolysis of spent coffee ground. Next slide, please. Okay, this slide shows our work schedule from week 7 to week 14 of this study. And the next slide. Okay, this slide shows the list of references that we used to perform this study. That's all from us. Thank you.